So students, in this video I'll be giving a little more understanding. I'll try to give you a little more understanding about derivatives or differentiation. So what we studied till now was about ds by dt, and then we saw that it is equal to limit when dt goes to 0 or approaches 0. We check the distance or the difference between the output or the difference between the distances, and that is t plus dt minus s of t. That is ds. ds is a change in distance. So this is a change in distance. And then we checked the change in time, and change in time is dt itself, right? Or t plus change in time is t plus dt. This was our one time, and t. So you subtract them both, you get dt. T minus t gets current, and you get dt. Of course, that is what our dt. The meaning of dt itself was the small addition to time. This very small value which is almost 0 that we are adding to time just to find the change in distance, because anyways, so so that is what we did till now, and let me make what we did a little more clear by telling you that we took a time t and we took a time t plus dt. This is what we did. We checked the distance covered at this time by looking at by taking s of t. S of t means the distance covered at t, and t plus dt, we took it as s of t plus dt. That means the distance covered at the time s of t plus dt. That is what we checked till now. Now this is very much similar to what you studied in relations and functions. That is, relations and functions, you studied that you took a x input and then you took an output. And what was the output? That time we took it as y, and we could also represent it as f of x. That means the function of x. Remember the function I was telling you about giving inputs and getting output. Getting an input, getting an output for every input. And so we studied that about functions, and when we studied about functions we saw about input and output, and this is two ways in which we can represent it. Either I can say that output I can represent as a y, or I could represent as f of x. This is a better way of explanation, because this shows what is the input. Because when someone writes f of x, I know that f of x is the output and this x is the input. The input is written inside. And when someone says f of t, I know that f of t is the output, t is the input. And so that notation or that way of writing gives you both informations. And when someone writes like this, f of x square, then I know that f of x square is the output and x square is the input, not x. X is not the input. X square is the input. The input values are not x's. The input values are the squares of x's. Okay. So, anyways, let us go on to the differentiation thing. So we studied this as a formal definition of differentiation. Now let us look on to a few questions. So find the derivative of f of x is equal to x square with respect to x. So we know that the output is x square because f of x is x square, and the input is this value x. So when you give an x, you're getting x square. That means that is what we are getting. So let us check what is happening. So let us substitute in our formula. So it is d by dx of f of x, which is equal to limit not dt, dx goes to 0, bracket f of x plus a small value f of x plus dx minus f of x, the change in output, whole divided by change in input dx. Now let me solve that, and what happens? This is equal to limit dx goes to 0, f of x plus dx is the squared value of that. That means f of x is x squared, so f of x plus dx is x plus dx whole square minus f of x square whole divided by dx. Fine. Now you know Pascal's triangle, you know binomials expansion, you know all the way how to expand this thing. So just expand it. Limit dx tends to 0, x plus dx whole square, a plus b whole square, that is x square plus 2x dx plus dx square minus this thing, that is x square whole divided by dx, bracket. Now if you look carefully, you will see that x square minus x square I can cut or cancel. So now it is equal to limit dx tends to 0, 2x dx plus dx square whole divided by dx. Now I can see that dx is here, dx square is here, and dx is here. So there's a dx in every term. So what I can do is I can take the dx's out. So it will be limit dx tends to 0, dx I'm taking common, so 2x plus dx whole divided by dx, dx and dx gets cancelled. Then what do you have? You have is equal to limit dx tends to 0, 2x plus dx, bracket, remember to put the bracket. So yeah, by the way, remember to put the bracket. Many of you don't keep forgetting to put the brackets, which I do see in the answer papers. So please do remember to keep the brackets. It will be confusing to you when you write the answer also if you forget the brackets. At the same time, it will be confusing for the person who correct the paper also. Okay. Now you apply the limit. So when you apply the limit, what happens? It becomes, this is a very small value, very 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 small value, almost it's equal to, it is almost 0. So the answer is 2 of x. So guys, what did you see till now? That's what I want to make clear to you. You saw that d by s, d of x square whole divided by dx, or d by dx of x square is equal to 2 of x, is 2x. You see that all that big thing, x plus dx the whole square minus x square whole divided by dx, it all got simplified into this it's very simplified formula, simplified expression, that is 2x. Now let me just try to show you what we just did, and for that so let us look in this. So this is the graph of x square, the function x square. This is the graph. Now what we did, or what we actually are doing in differentiation is, we are taking some value at, suppose this is my t. Okay, suppose this is my t, and I add a little value, small value. I add a small, wait, okay, suppose this is my t, and I add a small value to it, and I get, then this is my t plus dt time. Okay, t and t plus dt. Now what I do is I take the output at t. So this is my s, or instead of s I can write this is my f of t, or f of x in this case. Okay, in this case it was x, so I keep going to the t term. So f of x, if so, suppose if this is my x, and if this is my x plus dx, then this output will be f of x plus dx. And what we did was we checked the distance between this divided by this distance. That's what we did. Now remember, this is an expanded view what I'm showing you. In reality, the dx, the change is very close to 0. Okay, very close to 0. But if I cannot show that in this, because you won't be able to see it, of course, and I won't be able to draw it because it's a very small value. But to make you understand, I'm drawing an expanded view here. Okay, so this is what we did, and this is basically finding the slope. This is how you find the slope. You check the distance here, and then you were divided by the distance here. That is how you were taught to find the slope. And we also saw that differentiation is the slope of the tangent. So let us draw tangents, and when we draw tangents, we see that we see that the tangent value. So different slope of the differentiation is the slope of the tangent, and we got the differentiation value as 2x, right? So let us see. Now if the slope is 2x, that means the slope is a variable, because 2x is a variable, right? 2x is not a constant, it's a variable. So if the slope is a variable, then that means the slope should keep on changing, because variable means it doesn't have a constant value. So if you take, so in that case, suppose this is the slope at point 0. This is the slope, this is the tangent, and I know that the slope of this tangent is 0, because the slope of a straight line, horizontal line, is 0. Because how do you calculate slope? Change in y by change in x, and there's no rise here, there's no change in y, there's only change in the horizontal thing. So this is equal to 0. So basically this in this case you don't have a slope. So yeah, now what happens at this point? At this point, the tangent is this, and what is this? There is a specific slope, and at this point what happens? The tangent is like this, and you see that the tangent is changing. The tangent is changing and changing and changing, and therefore the slope of the tangent also should change, because the tangent is getting more. First the tangent was like this, then the tangent became like this. Tangent is becoming more and more and more steep. As it's becoming more and more and more steep, what happens is the slope is changing, and that is why the slope is a variable. You got the value as 2 into x. Okay, I think you will understand this in another example, which I will show to you the next question. So to take a look at this, find the differential, or find the derivative of x. By the way, derivative and differentiation are all the different. By the way, when I use the term derivative, derivative is the answer of what you get from differentiation is it's basically the same. The differentiation of x, I can say what is the differential of x or derivative of x. They're basically the same thing. Okay, so find the derivative of x with respect to x. So that means x is the input, because with respect to x I'm supposed to find, and I see that my f of x is equal to x. So this is my output. So what I see that when I give x as the input, I get x as the output. So what am I supposed to do in this case? Let's see. So before I go and show you through the formula, let us take a look at the graph again. So y is equal to x, or f of x is equal to x, graph is this. So here we see there's a, when x is 0, and let me take the, when x is 0.5, y is also 0.5. See, when x is 1, y is also 1, or f of x is also 1. See, so x is equal to, the f of x is equal to x, the input is equal to output. Now, so what is the slope, of the tangent, at these points? So let us check. In this case, at point 0, this is the tangent. At point 5, this is the tangent. At point 1, this is the tangent. Now what is the you see that the tangent itself is because for a straight line, for a straight line, the slope of the tangent is the slope of the straight line itself. That is why when you studied slope in the previous classes, you didn't learn it as slope of the tangent, you learned it as slope, just the word slope, because for straight line it is the same. The change happens when it's a curved. When there's a curve, we need tangents. So okay, anyways, so what is so if you look at this tangent is a straight line. So what is happening is the slope is not changing. The same slope, it is the same slope. Wherever you take the value, you see that the slope is the same. So what do you understand from this? Since differentiation is the slope of the tangent, it appears that since the slope of the tangent is not changing, and whatever is not changing, we call it a constant. So since the slope of the tangent is a constant, differentiation also should give us a constant value, right? So let us check that. So d of x divided by dx is equal to limit dx goes to 0. By the way, let me just make one thing very clear to you. When you see this different with respect to x, that means the denominator of the differentiation, your differentiation should happen with respect to x. This variable should be x. That is what the question says when it says with respect to x. Suppose the variable was with respect to t, then here you should have written t. So with respect to means that is what comes here. Okay. So now, so what you get, x plus dt, you can add as dt function, and you know that f of x is equal to x itself. So it is x plus dt minus x whole divided by, I'm really sorry, it is not x plus dt, it is x plus x. I keep going to the variable t. Okay, so x plus dt minus x whole divided by dx, and the dx value approaches 0. Now why didn't I didn't write f of x of dx here and I didn't write f of x here? Because both are the same thing. F of x is equal to x itself. Okay. Now next what happens is equal to limit dx goes to 0. If you look at here, you see that this x and this minus x I can cancel. So what do you get? Dx by dx. And what is that? Dx and dx I can cancel. So what do you get? 1. So you see that you got a constant value as the answer. That is exactly what is on the graph. You saw that in the graph the slope was not changing. That means it's a constant, and that is the exact value you got in the graph. Okay, let it be there for now. Now let us look into another question. What about the derivative of a constant? I